Hello and welcome. I'm John Ball, the CTO of Pat Inc. And today I want to take you through what the NLU basis of the new industry is going to be like. So the basis for a language understanding enterprise is having language understanding that works effectively to meet the requirements of users. And I've written about how this technology will enable companies like the New York Times in the future to publish the meaning of their articles into a lossless format, and then people all around the world can go and open that particular article and consume it in their local language. And in order to do that accurately, a lot of things have to work correctly that have eluded us in the past. And when I say us, I mean the scientists in the cognitive science field and AI field. But what we've done is by combining the role and reference grammar linguistic model with pattern theory, the brain theory that I developed in the 1990s, together we're able to solve the key problems that have held us back in achieving the NLU milestones. So today I'm going to take you through three things. I'm going to show you the conversation engine, how NLU is supporting that, what the breakdown of the language is, and then I'm going to show you the how we go and validate that all of that works. Traditionally, with a machine learning environment, a deep learning environment, you can't test it. It's a data-driven system. So you bring data into the system, and then you can test whether it's doing some of the things that you like, but it's not an exhaustive test. And what NLU needs to be is at the same level as human language. It needs to be exquisitely precise. Every single word and phrase needs to be recognized properly in order to contribute to the whole meaning of what is involved in the conversation. And the only way that can happen is with the approach that I'm going to show you. It's the meaning representation that comes from the field of semiotics. You're taking the words, you're converting them to their meaning, and then we're manipulating the meaning in order to work out what we want to respond to, and then we're converting the meaning into English in this case in order to understand what's going on. But it's easier if I show you. So let's move on to the demonstration. So this is the DevX system, the developer experience system. We built this so that customers of ours can trial what the system does, they can learn a bit about it, and then we can use it to prototype their requirements. And so there's a few different components, and I'll take you through what those are. So here's our introductory screen, tells a bit about the company and what the system is. But here's the conversation screen that allows us to enter text and get responses from the system. And here's the meaning engine that allows us to enter sentences and see the semantic breakdown of them. So one of them's the tool, the other one's the conversation engine that's closer to the product. And there's different things that will hinge off this for a proper user experience, depending on what the use case is. A couple of other things we've got here. There's a bunch of examples that sit behind this. I'm just going to show you the conversation and meaning interface, because I think, initially at least, that's a good way for you to appreciate the calculator of the 2020s. I've heard in the distant past that in the 1970s, students used to be given calculators to learn how to use a calculator, but when a test came up, you had to use mathematics in order to solve the problems. You weren't allowed to use your calculator because that was a bit like cheating. You needed to understand how it worked. So in this case, we're looking at the calculator for NLU for the future, where users can reference to this in order to get knowledge of NLU. Excuse me. Okay, so let's start by just running through a sample. I'm going to load a text file so that we can step through point by point. I'm just going to run them all, and we'll have the synthesizer running in the background. I'm not sure if the mic's picking this up or not.
Who sold the car?
You can probably hear that.
Who received the car?
So the point of this example
Man paid for the car.
The dealer.
is we're showing how the meanings of words can still combine in such a way that it's extremely useful.
Who was presented with the car?
Okay, I think we're nearly done. Who was presented with the car? What was the man presented with? Okay, so we've put in the information, how the system works. If the sentence is a statement, like this, the man bought a car from the dealer for $1, we store that in context for use. If it's a question, we simply look at what's in context in order to use it. In discourse pragmatics, the storing of that information is called the immediate common ground, or context of utterance, or context of situation, depending who you talk to. And we can show you that here. We've broken down the man bought a car from the dealer for $1, right? Nothing up my sleeves, there's no tricks going on here. This is just the application of science. We have the semantic representation of that, but inside that we also have the meanings of the phrases that have combined. So for example, there's a transfer of money here, where the man doesn't have the money and the dealer does have the money. And we've also got a transfer of goods. So the man doesn't have the car, then he does, and the dealer does have the car, and then he doesn't. And so by simply taking the meaning of the sentence, we're then able to ask questions in real time and see the answers popping out as you've seen. So here's the point of this particular example. The man bought a car, and then we ask who sold the car. So if the man bought a car from the dealer sold the car to the man. You can argue whether you would be a bit nitpicky about this example, but I'm making the point that the word sold does not appear in that original sentence. But who sold the car? The dealer did, right? Because the dealer was who the man bought the car from. Who received the car? Well, if you buy a car, you receive it. So the man did. Who did the man pay for the car? Who did the man pay for the car? The man paid the dealer, because the man bought it from the dealer. So the man paid the dealer for the car. Who was sold the car? The man was. Notice here we put the man was when we're asking this type of question. There's variation allowed, but we're trying to be very specific with our answers in this system so that we can help the user, sort of hitting them over the head with a club by using English in a very specific way. Obviously the correct answer could also be the man. We're saying the man was just to be extra clear. If you say the man was and it's incorrect, it really strikes you. It's like being slapped in the face, because if you speak English, these concepts are very precise. Did the man pay Beth for the car? No, the dealer. So here, we don't say the dealer was, because that would be incorrect. And we're saying, did the man pay Beth for the car? We're saying no, the man paid the dealer for the car. And just those words, no, the dealer, is sufficient. And what we're trying to do with this system is to make it very natural. So in the design, and if you were a sci-fi writer in Hollywood in the 1960s, you would always be saying affirmative, negative if you're the machine. But that's not helpful. What a person does in conversation is they're helping to communicate. The whole point of conversation is to communicate. So if somebody asks you a question, you don't just say no. It's not a courtroom. You're trying to help. And so when you say no, the dealer, you're acknowledging the fact that in this current conversation, you know not that answer, but you know an answer that's going to be helpful to the speaker. Who was presented with the car? The man was. Is presented with a good predicate when you bought something? Well, normally you present somebody with something if it's a prize, but you understand what it means. And so an NLU system has to understand as well as a human in order for the system to be that breakthrough in technology that we want. With the calculator example I used earlier, if somebody allowed you to use a calculator and it gave the wrong answer 1 out of 100 times, that technology is no good. And today's NLU does not give you 100% accuracy, but this science behind this will allow us to have human-like accuracy for all of the IT applications that need a language interface in the future, voice or text. What was the man presented with? The car. So all of these questions get answered correctly, and the whole goal of NLU is to give 100% accuracy on all of these tests. At the end of this, I'm going to show you what our scientific model is for covering all of the cases, because I mean ultimately there's an infinite number of examples that we can show, but the intent is that by simply covering a predicate in sufficient detail with the variations, which I'm going to be showing you in this demo, then the system is ready for testing. And once the tests go in that cover all of those cases that we put from the linguist perspective, once we've done the implementation and the tests all pass, we know that that is going to continuously work forever. And the concept in computer science of regression testing is once you've got your system working, when you make changes to it, like you're adding new vocabulary, if you then rerun your tests as a regression test and they all pass, your changes haven't affected your production system. So that's the type of virtuous circuit closed loop that we've implemented in order for NLU of the future to be human-like, to have human-like accuracy and meet the needs of the next generation of computer users. Okay, so that's the conversation engine. Let's have a look at the meaning matcher. In the case of the meaning matcher, it's not doing conversation, it's breaking down the meaning of sentences. The reason I'm going to show you these is that each predicate can have arguments. I'm using some technical terms here. So verbs have arguments that compose the meaning, and you can put in very large numbers of arguments and get the same meaning. There's a thing called selectional restrictions that limits them, but now I'm probably just boring you with technology mumbo jumbo. The point is that these are extensions to the predicate. So when we say Mary wiped the table clean, there's actually two predicates here. You can see in the center here, Mary, we've got wiped and clean. So you have to understand what those meant in that sentence. And so here we've got the meaning that the system captures. We've got an activity, which is the wipe activity, and there's its arguments, Mary and the table. So Mary wipes the table, that's an activity, and that causes, right? So there's our causality baked into language. It causes the table to become clean. Was the table clean at the beginning? Well, don't know, but at the end it was, so the table became clean. So these semantic relations are sufficient to drive the conversation example that I just showed you. And so that's one of many examples of interclausal semantic relations. What does that mean? So you can have multiple clauses, multiple sentences where they can potentially share arguments or have causality or something. And those relations, which are defined in the role and reference grammar in a remarkable way across the world's languages, the explanation of that is covered in 2 pages with something like 20 different categories. Some of them are completely open-ended, and some of them, like this, are quite specific. You can't wipe the table run, for example. It needs to be a state that finishes that particular construction. What else have we got? We've got, let's see, started singing. What does started singing mean? There's 2 predicates there. In this case, we've got a temporal start. So the word start is giving us the time that this activity's taken place. And this is the time of the activity. So in the semantic representation, we see the activity Sam sings. But we're focused on the start of the singing. So you've got a start, a middle, and an end, a finishing of singing, a starting of singing, a continuation of singing. The language is so precise because we can take these activities and we can specify where we're talking about in that particular event. It's pretty remarkable. And so you need to be able to, in an NLU system, recognize that correctly. That's started. What about kept? If you keep doing it, you were doing it before, and now you continue doing it. So here we see if Nancy kept crying, Nancy is performing the activity of crying, and we've recognized here temporal keep, so that's continuing. Notice here too that we have definitions. So this is a symbolic system in that we're using word senses. The meaning of the word cry has been resolved to being weep, and you can see shed tears because of sadness, rage, or pain. That's a definition we've entered just so we know what the word means. But the only thing we're using is that P:"weep. It's the symbol that represents that particular interpretation of weep. And with Nancy, we've got that it's a woman's name, and we can obviously build up knowledge about individuals as humans do by introducing concepts and tracking them in the immediate common ground and then archiving it to be our background knowledge. Okay, that's keep. What else have we got here? There's more complex examples of these relationships. I think of them as more complex when you get to the core sharing of arguments. So Mary lets Sam wash the dishes. What does this mean? So Mary let. So let has a meaning which is roughly Mary does something which causes something to happen. In the case of let, you can see that it's to compel or make somebody act in a certain way. Facilitating is not forcing. There's different words that'll go along the spectrum of forcing to, facilitating, somewhere in the middle to permitting. So Mary let means Mary causes something. In this case, Sam washes the dishes has this meaning. Sam does something which causes the dishes to become clean. And when you take that and you embed it in that X that you had in the what let means, you finish up composing this result. Mary does something, don't know what it is because she let Sam do it. That causes this whole thing. Sam does something which causes the dishes to become clean. So again, causality is exquisitely baked into English and other human languages. And if you can understand the causality, you're on the path to helping people do the things that they're trying to do, because often people are causing you to do something for them. Sorry for bumping that for the 50th time. Okay, so you can see in these interclausal semantic relations, there's a lot of different types of connections between multiple predicates that get a particular result done. Okay, so let's go back to our conversation engine and then look at a different application. So I'm going to take a different file here, and we'll get into the DevX system and how users can operate with that without using these files. But for this presentation, it's just a bit easier for. Let's see if I can upload the correct file. Okay, so let's run them all again. The man carried the toy to the beach. So there's our statement of fact. Now we're going to interrogate it with questions. This is pretty much the system that we're using in order to validate that we've understood one of the levels. That one level is the meaning matcher. Do we produce what we expect? If we do that, does the system work in context, in conversation, as we'd expect?
Yes, he did.
Okay, so you notice that the system's much faster than the speech synthesizer. That's important for NLU because the system has to potentially go away, find some information for you and bring it back. And in a conversation, if you had to wait for delays, that would be sad. And so, in fact, the system, you can see, can cover up for delays in it doing some sort of back-end interaction with an enterprise system by simply speaking, because the speaking is considerably slower than the recognizing of the language. Okay, so what's going on here? The man carried the toy to the beach. Okay, so there's a lot of focus in the AI community about inference. How does inference work? We need to reason. We don't know how to reason. That's a big problem. It's unsolved. Well, you're seeing it working in real time here. And the way it reasons is by not reasoning. It does inference by understanding. And if you understand, you don't need to go and find out what it meant because you already know. What does that mean? Well, let's have a look at the examples. The man carried the toy to the beach. Where is the toy? Well, if you carry the toy to the beach, the toy's at the beach. And the answer is at the beach. Notice it could also have been on the beach. At the beach is more general. So it's somewhere at a point on the beach. We don't say it's in the beach because you'd have to bury it. We don't say it's above the beach because you're not specifying that. So we're simply following what's being provided and then interpreting it with a general way. And NLU has to do that. A language understanding system has to understand to the point where it can answer you as a person would. Who has the toy? Well, if you carry the toy, the man has it. But notice here we say the man did. Did is past tense. Why didn't we say the man does? Because, again, it's very precise. The man carried the toy, so that's past tense. Does the man have the toy? Well, don't know, but he did. So we're saying, does the man have the toy? He did. Or who has the toy? The man did. Sorry, I think I just got confused with the lines there. Does the man have the toy? He did, so same reasoning. Did the toy move to the beach? Well, the man carried the toy to the beach. That means that the toy's at the beach, right? And so, yes, it did. It did move to the beach. It's moving as well as being carried. Did the man move to the beach? Yes, he did. The man's moving, well, he carried it. So as long as you understand what carry means, you know that these are the correct answers. If we look at the current context, you can see that the meaning of carry is the whole sentence here, plus it's the possession concept, but remember it's possession in the past. And then we've got the actor moving and the undergoer moving. So the man moves and the toy moves and finishes at the beach. In role and reference grammar, the concept of actor and undergoer is how the syntax is converted to semantics. It's part of the linking algorithm. And so we're using the scientific principle in order to do the correct interpretation, in order to give the correct answer. Okay, let's go back to the meaning engine. So again, that was the conversation engine. Let's have a look at some other examples. Nominals. I showed this to our group, which is why it's relevant, where I was making a couple of specific points. Actually, there's a couple of extra points here on top of nominals. So nominals is where you take a sentence and you convert it back into a noun phrase and then you inject it as part of a larger sentence. So that's the key focus here. But notice we can have a sentence like, those are ugly old red, white, and blue cloth flags. So ugly old red, white, and blue is a phrase of its own. It's a reference phrase. And it's got its own meaning in addition to the full sentence. So the flags, that whole phrase actually means flag. It's the piece of fabric, but it's a particular one. So if we click here on the phrase, we can then see that ugly old red, white, and blue cloth flags means they're old. It also means that they're red, white, and blue. It also means that they're made of cloth, and it also means that they're ugly. So you need to be able to pull all of that information apart. I mean, how we're doing it, you can see we've got the main referent being flags, we've got an opinion, we've got an age, old, we've got material, cloth, and we've got color, which is actually a conjoined idea, red, white, and blue. And what we do in our system is we're matching each of the same types of elements to a common element, and then we just number the elements. So 1, 2, 3, red, white, blue. One of my idols from the past, one of the great scientists, was George Miller, the cognitive psychologist. He came up with this idea in the 50s that was the only thing that a human brain is remembering is 7 plus or minus 2 ideas at a time, concepts at a time. So we've built our system to be able to cope with a conjunction of up to 9. So that should be human-like, and of course the accuracy of this will be higher than a human because it's running on computer. It doesn't have the same types of memory limitations that we do. So that phrase has that particular meaning, and then you can interrogate this full representation in the conversation engine. So, was the flag ugly? Yes, it was, because we've just said it. Here's another one. So when we talk about motion, and you're thinking this is just all pretty easy, anybody can do this. When you get to the real use of natural language, you get stuff like this. The woman flew 10 parsecs. So 10 parsecs is a distance. And notice we recognize it down here as a distance. And what does it mean? It means the woman moves with a manner of flying. So that's what fly means. And then we're covering a path where the path has a distance of 10 parsecs. So the woman is going over that distance of 10 parsecs. And you would think that's trivial, but if we take that sentence and change it a little bit, the woman flew the dog. What does that mean? Well, here we've got the woman causes the dog to fly with the manner of flying. So that is actually a causal connection. See, we've got here an effector, the dog. So if you fly the dog, you cause the dog to fly. It's an unusual expression, obviously. But if you fly 10 parsecs, you're the one that's flying, and then the distance is the 10 parsecs. So those types of things look like they're really hard to address with traditional science. I mean, this has been discussed for 60 years, so we've got a working system that's showing it in operation. It's been quite a while to get this sort of positive result for problems like this. And the point I would make is that this is not just pattern brain theory, it's not just role and reference grammar, it's also the expertise from semantics, it's the amazing people of the past that we're standing on the shoulders of in order for this stuff to work. The woman flew 10 parsecs. In fact, if I've still got that, you can obviously extend these types of things with phrases. So 10 long parsecs is now the distance that we're covering. And you can go into the detail of 10 being the number, and we've got another modifier in here, which is length. And normally that would show it as a different dimension, but anyway, the system is able to deal with this arbitrary embedding of concepts inside of other concepts, and that's why language isn't just the numbers of words and sequences we're recognizing, it's all of the combinations that are taking place to build the phrases, to build the correct representation of the meaning. The point of this particular sequence, though, is the concept of a nominal. So if you got the payment of $1 by John for the red car to the dealer being good, if you have that phrase, the payment is actually what we call a nominal nucleus. It's a predicate that's in a noun form, to use the old terminology. And at the bottom here, for the car to be paid for by John, paid is the verb form. So paid and payment are the same concept. It's just that you use one of them in a noun phrase as part of something, a larger sentence, as opposed to it being the source of the sentence. In fact, this is also it's an infinitive form. So infinitives are phrases that are nominal forms of verbs, and these derived nominals are reference phrases or nouns. So anyway, if we have a look at the breakdown of this, the payment of $1 by John for the red car to the dealer was good. That payment of $1 is a sentence in its own right, and you can see what it means. John does something, John's the one paying, causes John to have the red car and the dealer not to have the red car, and at the same time, and also, it's a separate transaction. The dealer has $1 and John doesn't have $1. So in this case, the transfer was for $1 for the car. And that's what payment means. And you can see that payment is, we don't have a good definition there. E-pay means that it's a event of pay. And if we go back here and we look at another example, for the car to be paid for by John, now we're saying for the car to be paid for by John, that means John paid for the car. And John does something which causes John to have the car. So that's a much shorter use of arguments in the predicate for pay. Let's just see if we've got any other meaning examples here that I wanted to show you. So that was nominals. This is the last one. Okay, so the difference between limping and entering a room. Some languages use this entered the room as the main way of talking about that sort of motion. So here you've got Beth entered the room, which means Beth does something and she finishes in the room. So when you enter a room, you don't say enter into the room. I mean, you can, it's still understandable, but one of the benefits of the word enter is you don't have to say into because it's implied. And then we've got Beth limping is the second part of this relationship. Beth moves with a manner of limping. So when you take this whole semantic representation, you've got Beth moving, she's entering, which then means that Beth finishes in the room, and then she has a manner of limping. So that's how enter is interpreted. And if you take this probably more typically English way of expressing it, Beth limped into the room, you can see the representation here is Beth moves with a manner of limping, and then she covers in this process a path where Beth finishes in the room. So the representation of the two is pretty much the same. The reason we have this flexibility in language predominantly is because the brain has no problem with doing it. But in terms of NLU, as long as you can recognize what the meaning is and then combine it so that it's used correctly in conversation, then our system's working correctly. One other example, I think it's kind of cute to see. If you make a cake from a mix. So here we've got Beth made a cake from a mix. You've got the activity of Beth making a cake, but in this case, this particular creation verb also is specifying the material that you're using to produce it. So if you make a house from bricks, bricks is one of the ingredients you've used to build a house, to make the house. So here, at the end of that activity, after you've done the mixing with the mix, you finish up that the cake exists. So here we've got the theme, that's the thing that was being made, which is the cake, and then the material that was used is a mix. So that's one of the meanings of made. But you can make a cake without a mix. That's it. When I looked at this, it's sort of mind-bending. Well, what does without mean? Well, in this case, you make a cake, but you don't use a mix, and then the cake exists. And then there's another way. You can make a mix into a cake, so you can focus more on the mix, and then it becomes the cake. One of the amazing features of language like English, like all languages, is that you can change the orders in a very predictable way in order to convey the meaning. Notice here, Beth makes the cake using a mix and the cake exists. It's exactly the same as made a cake from a mix. So as long as you can understand how these predicates are being produced, you then got a good way of using the language in an NLU system. I'll just use one more example here. A cake was made by John without a mix. So now we're flipping the topic of the sentence from John doing the making to the cake. So now we're focused on a cake was made. This is the passive versus active in languages like English. But notice here we've got John makes the cake and doesn't use the mix. So that was the same as the without meaning. And then at the end of the activity, the cake exists. So this level of recognition of language is so powerful and so useful. And by the way, this was the goal of NLU NLP, in fact, in the 70s and 80s, to be able to do this. But with the parts of speech model and the combinatorial explosion that the parts of speech model creates, also by excluding meaning, we haven't progressed, and we've now finished up with the next generation of systems being statistical, first with statistical specific solutions, and now with machine learning and deep learning based statistical solutions. But going back to this symbolic method, it's showing great promise. We've really got the potential now to move into a new industry based on natural language understanding, where the interface is going to be human-like. All right, so let's move from those examples into a quick overview of what the DevX system's doing that doesn't require you to have that same degree of, you don't need to load files, you can just work through the system. So we've broken it down semantics, so we've got predicates, we've got the different types of states, the different types of activities, we've got the transfers that I've shown you examples of. Let's choose a consumption example, because I'll show you a consumption example that we're using to test to make this into a proper industrial level solution. So here we've got the girl fed. So we've got feed and eat. So what's the difference between feed and eat? Eat is a two-role activity. You're eating something. Feed is a three-role activity, or two roles plus causative. Basically, feed means cause to eat. And so in the two-role cases, you can see we've got girl eating food, and then a bunch of different sentences that we'll want to test the meaning of. And then with feed, you really get into a combinatorial explosion of different ways of using feed in sentences. We test, I think it's like 1,200 specific cases, so that we're certain that the system's working correctly. But if we use the meaning engine here, if we look at eat, you can see that there's your two-role activity. It's an activity because we've got girl, we've got do here, we've got girl, which is the one that's doing it, and then you've got, as part of the activity, the girl is the one eating the food. The food's the thing being eaten. And this is, in fact, called an active accomplishment. So at the end of the activity, the food has been consumed. So there's a resulting state here. So that's our representation of eat. You can look at feed. Let's take something. It is the children that the girl fed the food to. So there's a bit of a mind twister for when you're not quite in the moment. So it is. So we're recognizing the children that the girl fed the food to. If we look at the phrase there and we drill down into it, you've got the girl fed the children the food. This is my terminology, cause, effect, or effector. But this is the pure RRG, role and reference grammar, semantic representation. The girl does something which causes the children to eat the food, and at the end the food's been consumed. So we're simply adding causality to the eat predicate in this case. Okay, so that's one of the categories. You can go through and look at one role states such as, the dog upset the cat. This is the dog causes the cat to be upset. So upset is the one role predicate, but you've got the causative form where the dog causes that. And you can use those sample sentences in conversation. Let's just run them all. So the dog upset the cat statement. What is upset? The cat was upset, not the dog, because the dog upset it. What upset the cat? The dog did. So there's a polar question. There's a content question. What upset the cat? Did the dog upset the cat? Yes, it did. So we're asking a polar question about the whole event. This is asking a polar question of a piece of the event. Oh. And was the cat upset by the dog? Yes, it was. So all of those answers are correct. Notice here when we say, is the cat upset? We say, I don't know. I've had a world-class linguist look at this and say, world-class engineer, I should say, NLP guru. And she said, that's not right. Doesn't know. Well, actually, if you say the dog upset the cat, so that's past tense, and then you said, is the cat upset? You'd say, I don't know, because it was in the past. Well, maybe it was upset, but now it's not. So when you say, is the cat upset, you're asking about the present. So we say, I don't know, but it was. So kind of a cute example, got into trouble for that, but you got to be precise if we're going to do NLU properly. So we can run through, transfers. You can see that we've got a bunch of examples that we can test. The other part which has held back NLU for decades is this, error correction. When we launched the company in San Francisco, the American company, which is now the Pat Inc., in 2016, we started with this very simple expression, call Beth, no John. What does that mean? Does it mean call Beth? Well, hope not. It means call John. But if you put that into devices like Siri, for example, often it would come back and simply call Beth, because statistically, call and Beth are co-located. They're right next to each other. No John is a long way away in distance in terms of the sequence of words, so it would choose call Beth. But if you understand what is being said, you would call John. So if we click on that, you can see that it's a command, it's an imperative, and who do we call? We call John, not Ghostbusters in this case. But if you said call Beth, no text, this is a discontinuity, but text doesn't mean, it's not a thing, it's a predicate. So this means text Beth, call Beth, no text. So when I put this into a conversation, I'll just run the whole lot. Call Beth, no Samantha, no John, no text. So call Beth, no Samantha means call Samantha. And then you change it to no John, you're now talking about calling John. And then when you say no text, you mean text John. So the only thing we've said here is text John. How do I know that? If I check the current context, you can see we've recognized text John. When questions are asked, who is called? I don't know, because John was texted. Who has texted John? And it's very important for NLU to know when it doesn't know. just because there's an answer that's close doesn't mean you should blurt it out. That was one of the the glue tests, one of the tests that were done up the road in Palo Alto at Stanford. I think it was was the glue test, and then super glue came after that. Could be wrong though. So anyway, the AI tests that were doing things like this realized that you don't just want to give an answer or a test. You don't want to run a test without testing for the system, giving the wrong answers for things that it doesn't know about, which are otherwise co-located. There's an error from the generator. Was John called? No, but I texted him, I guess, is the correct answer. Okay, so that's an example of error correction. There's a bunch of other things, modifications. Let's look at conjunctions, because I think these are kind of cool to look at. If you said the girl is tall, happy, and sad, you need to be able to get these conjunctions correct. So tall, happy, and sad is basically tall. It's 1, 2, 3. We're numbering these things: tall, happy, and sad, and then you can get the meaning of tall by clicking there. You can see that tall means tall, taller, or tallest, depending on the additional precision that you want to add, and then we've got additional information about that. So in terms of attributives, you need to be able to conjoin those. You need to be able to put them in a sequence and recognize them without losing anything. And yeah, there's just a bunch of different examples. Did I do this one, or was this on the previous example? So we've got flags here where those are ugly old red, white, and blue cloth flags. I'm going to do it again because I really want to stress this point, just in case I didn't do it on this particular video. So notice here that phrase means flags, and if we click into it, you can see that we get the fact that in an opinion, it's ugly, its age is old, its material is cloth, its color is red, white, and blue, and you can drill into red, white, and blue, and again you get the conjunction form where you're seeing the different components that make up that. And again, we can track up to 9 of those in our system to align with George Miller's approach. Okay, so let's move on then from the DevX system to how can we make this work? Because it's great that I'm showing you something. For all you know, I've just hard-coded all of this stuff in the background, and I'm just showing you these answers because the system doesn't really work. But trust me, it does. And the way we go about it is by taking a linguist's input first, working out how each of these elements, like with the attributives, with these categories, we have to look at how does this word work, and what types of sentences do we need to test it for. So for example, if you have something like this, we're looking at source of information, which is apparently. What apparently is doing is it's adding to this whole meaning representation that it's evident. So we're giving our source of information. It's whatever evident means. It could be obvious that something happens that's different, but if you just gave the sentence without apparently, what you'd be saying is that this has happened. You're not qualifying it at all. But if you add that qualification, apparently, you're now saying that whole thing was evident. I've got evidence for it, I guess, would be the proper interpretation. So what a linguist needs to do is write up all the test cases that will cover that in general. You don't need to test the Beth is continuously moving to the kitchen slowly, because that's covered by the motion predicate tests. But the apparently test has to cover a couple of these just to be sure that we're working correctly. And you also need to make sure that if there's some places you can't use it, that we definitely don't accept it as valid. So what that looks like, let me go to here. This is the feed class. So it's that 3-role example that we went through. So here's some words that are in that class. If you spoon feed something, bottle feed, nurse, all of these patterns should work. And there's some nominals. Like if you feed someone a meal is is something quite specific to this predicate feed. So then, from a linguistic perspective, we're looking at, is it causative, consumption, let's see, activity. Because it's three roles, it's got this concept of dative shift where you can say, I fed this to someone, or I fed someone this. They've got slightly different meanings, but the same semantic relation. So somebody's gone through and worked out the class components. We've got the variations that are being tested. Here's an example sentence. The burgers are evidently being slowly fed to the children by the babysitters. We're not going to test the fact that you can put evidently or slowly into this, because that comes from the more generic activity class. But we're going to test all the other elements of this. So how do we do it? Well, what are the components that are worth testing for? Well, you can have positive and negative examples. You can have active and passive voice. You can have tense, which is present, past, modal tense, so future tenses, and then aspect, so perfect, progressive, or both, perfect, progressive. So you can see here, maybe you can see there. Can I make this bigger? Maybe we can. Let's go a little bit bigger. Okay, that might be easier for you. So here with the first test, we've got the man feeds food to the dog. So that's in this group. It's the we've got one argument, the man. We've got food, which is the second argument, and to the dog. So all of these examples generate what are known in RIG as operators, but in addition, they're generating this semantic relationship. So not only does the man cause the dog to eat the food, in that the man fed food to the dog. Notice we don't have the active accomplishment form. We'll see that again in a moment. So, and ingressive food is consumed. Notice that it's not that type. And the reason is because we're feeding food, which is the activity form, not the active accomplishment form. I'm talking too much again. Let's keep going. So the man feeds food to the dog, that's positive. The man has fed food to the dog, that's the perfect form. Progressive is feeding, so it's currently taking place. Perfect progressive has been feeding food. All of these come from about 5 patterns. So it looks like we're doing a lot of testing, and we are, but the patterns that drive this combinatorial explosion are very small, which is what makes this very scalable. So what's the difference between active and passive? So in the active case, the man feeds food. In the passive case, we swap the actor and undergoer. So food is now the first argument, and the man is now marked by the word by. Food is fed to the dog by the man. So it still means the man causes the dog to eat the food. So as we go through this, let's go to a negative form. So in the modal forms like will, when you make it negative, you can say will not, will the man not would probably be the English form, like in I Dream of Jeannie. Won't the man is the single word form. Won't the man be feeding food to the dog? That's the progressive form using the modal tense. And obviously, in terms of modality, we're going to test will, shall, can, should, would. All of those go into the tests for that, whereas in this case we're testing the predicate, so we're just testing using will, in this case will and won't. So positive, negative, and then we can go through, here's the second test. So in this case, instead of feeds food to the dog, we're saying feeds the food to the dog. So now it becomes an active accomplishment, and you can see in the logical structure that we want to test for, the food is consumed at the end. So the man causes the dog to eat the food, and then the food has been consumed. So that's the second case that we're looking for. Notice we're at 190, now we're up to, let's see, this is causative activity dative shift. So in this case, here's the logical structure. It's identical to the first one. Semantic relationship, the other way we can talk about it. The man feeds the dog food. So in this case, the food to the dog is now, that order's been swapped. The man feeds the dog food. And so here's our tests that are looking at the dative shift. We've got questions, we've got statements, we've got commands. Right, and you think, oh, okay, well, this is going on forever. That's a bit boring. But anyway, that's what you have to do to be exhaustive about a testing regime and then confident that the system's going to give 100% accurate results. This is the type of thing we would have done when we were producing calculators if you weren't sure that you were producing the right answers from the calculator. And the other obvious point is it's now possible to do that with this tech. We can now test exhaustively and be guaranteed that the next time we run the tests, they're going to pass if we haven't changed our system. Okay, so here we've got not dative shift. We've got the man that feeds food to the dog. So now we're creating a nominalized sentence. So we're focused on the man. That is the man that feeds food to the dog. And we're going to test the fact that the man that feeds food to the dog, the man feeds food to the dog is the semantic representation here that we're getting, despite the fact that we've got that's in that sentence. We've got present, past tense, modal. Here's another type of nominal. Food that the man feeds to the dog was tasty, for example. So another nominal form. In this case, we've got food is the referent that we're focused on in that sequence. So that is food that the man feeds to the dog. We're focused on food. But you can change all of these orders. That is the dog that food is fed to by the man. That is food the man fed. That's past tense. Let's go to this next one. The dog that the man feeds food to. So we're going to make sure that every possible permutation is being tested. And then we get to the noun forms, the nominal words, derived nominals, action nominals, if we have them. And we're testing, let's see, this is infinitives. So for the man to feed food to the dog. Gerunds, the man's feeding food to the dog. The man's having been feeding food to the dog. Notice this one's crossed out. The man's eating food. It's not valid, but it was in our original test because we simply went through the permutations and then we realized in English this doesn't make any sense. Light verbs, you can have light verb constructions. We're not testing feed in this case at this stage. And this was an earlier draft, so I'm not sure what the current version is. So here's more, the man that feeds food to the dog, two role causative activities. I don't think we had a nominal form here, like in the case of destroy, you've got a derived nominal destruction, the destruction of the city. I can't think of a word for feed that means the nominal, the feeding of the food is a action nominal, not a derived nominal. Okay, so as you can see, running through test case after test case after test cases, and so I think this class basically had four main blocks of things to test, and then you've got the verbal forms and the nominal forms, and so this is how we're going about testing NLU. And once you've got a class like feed, if there's other words that are in that class, the testing's already been done. You simply associate one association in our database that tracks this, and all of these tests will pass because this passes. What's a test look like? Let me see if I can stop sharing that for a second and let's present. I'm going to present that whole screen, I think is probably the easiest. Let me move that away. So I'm going to show you some Visual Studio Code here, but I'm not going to run through all of the tests, but you can see here. Let's see, we've got an example like how does the test work? We put into the meaning matcher for this particular example, the girl fed the children. This is actually an exception to the word feed. So if you feed the children are the ones who eat. you can feed the food to the children, but if you leave that extra argument out, if you just say I fed the food, you mean you're making the food eat. It doesn't make any sense. So we're just testing to make sure that that two-role example works. And so here we're making sure the cause effector is the girl, the nucleus is fed, that's the predicator, and the effector is the children, which is the thing eating. And then you can look at it in a different type of phrase. It is the girl who fed the children, so basically just mimicking what we've got in our test case. So the girl fed the children is cause, effector, nucleus, and effector, and you've got to drill down into the phrase that comes back because the sentence includes the it is part. So a different type of test. This is a more detailed test. Let me see if I can center that for you. So here we've entered the man feeds the dog food. So we don't mean the dog food. That doesn't make a lot of sense. Feeds the dog food. Feeds food to the dog. So here we see that the cause effector is the man. That's the thing causing the activity. The dog is the effector, the thing that's eating. The theme is the thing being eaten, which is food. And the nucleus, the predicator, is feeds. That's for our internal use, the phrase that we're using to match the final semantic set is that one. And here's our semantic representation. The man causes the dog to eat food. And again, we don't have the active accomplishment form, so we don't have the consumed food at the end. Some other things we're testing for. It's positive, not the negative. The man didn't feed the dog food, and it's present tense. The man feeds the dog food, not the man fed the dog food. And so as we scroll down here, you can just see test after test after test. All of our test suite runs in about 15 minutes, so it's not a big imposition to make system changes and then run your exhaustive tests at this level in order to validate your system is working. And by the way, not all customers should have to go to this level of detail because we're providing a system that has already done this work. So we're simply providing a pre-tested system to you as a client. So I think that's pretty cool. In terms of tests, I think it is the man that feeds the dog food. It's just a large number of tests that is very much a IT person's job to do compared with the linguist job of writing the specification. But we see that the combination, we go back to, let me move my cursor to the right place. At this point, you can see that with the vision of taking text and converting it into meaning, the way that works in an industrial form is the meanings of these different phrases is being analyzed by linguists using the role and reference grammar theory. So the theory is pretty good. It's been running for a long time. It's got lots of languages covered, and the representation in terms of the mapping between syntax and semantics is pretty well accepted across many languages. So that piece has gone very well. There's other information that comes from semanticists. One of the semanticists that also worked at Heinrich Heine, where Professor Van Velen worked for a decade or so, that semantics work we use to augment the interpretation of those sentences so that we can drill down into word senses and the hypernym associations, meronym, holonym associations. So if you can get the science right, you can get the IT right for this type of testing methodology, then we're all set to go with the next generation of NLU, the industrialization of NLU for IT. And then the amazing future promise that we've got where the world is brought together because we're saving things in a meaning-based representation and then allowing users to consume that meaning in the language of their choice. It also has many other implications like for translation and voice improvements and the like. Because at the moment, voice has the similar problems to the deep learning problems that we see in chatbots, with lack of generalization and too much reliance on statistical on the probability of the sentence rather than the meaning of the sentence. So there we have it. Thanks for joining me today. Look forward to seeing you at the next one, which is talking more about the industry. And I thought it was worth deferring that to a panel discussion so we could get this one out of the way, which is the engineering method that we're using to make all of this work. Okay, bye for now. Thanks for joining us.